we want to welcome you for this hour. All of you have a folder, and my name is Cristina Corchado. I'm the CPIN coordinator for Region 7, and this is Diana Decker. Both of us are going to be doing this presentation, and we're really happy to be here with all of you.
Is there anyone who doesn't have a folder? Just raise your hand, I'll bring them to you.
Okay. So if you want to come and collect the folder for your table.
It's one for this?
No.
Make sure that everybody has a folder.
No, these are in here.
Oh, thank you so much.
Thank you. That way we can go over the handouts.
Anybody else?
Thank you, ladies. Everybody has a folder? If you open up your folder, make sure that I want to make sure that you have all the handouts that you need today for this workshop. On your left side, you have the PowerPoint for you to take notes. And on the right side, you have a resource that we're going to use. And then we have handout 1A, which is to take notes. And then handout 1B, the foundations. Handout 2A, language and logical reasoning. And handout 2B, materials. And handout 3, creating invitations throughout the environment. Everybody has those handouts? Just want to make sure that all of you have your handouts that you need for this presentation. Everybody's okay? All right. So today we're going to talk about math reasoning. Mathematical reasoning is the key process in learning and develop mathematical knowledge in all the areas of mathematics. And we all know that it comes really natural for children, this process, as they explore their environment and they explore and learn new things in the classroom. They just think logically and make sense, right? Because you see it every day in your classroom. And also, mathematical reasoning plays into the other content areas, like in the science area, in the literature, and in all of the areas. And we're going to kind of talk about that today to get us started on that process of mathematical reasoning. We're going to encounter a little bit of a STEM challenge. How many of you are familiar with this? Jack be nimble, Jack be quick, Jack jump over the candlestick. So Jack has a little problem. We're going to help him with this problem. This is Jack, and he has to jump over the candlestick. But what has happened with him, he hasn't really done any exercises lately, so he's not strong enough. We have to help him. This is where your mathematical reasoning is going to come into play today. So you have these bags on your tables, and you're going to develop a little device to help them safely. But this is the candlesticks. That's why you have a candlestick at your table. And I want you to take out resource number 1. Let's go over resource number 1 before we do anything else. Take out your resource number 1. And on your resource number 1, it states the problem. This is what's happening with Jack. He forgot to do his exercises, but he needs help. And in pairs or triads at your table, I want you to follow the directions and devise your plan. What I want you to think while you're doing this, creating this device, what are the mathematical reasoning behind this activity and how it's tied to STEM and to science? So let's take a couple of minutes and read your instructions and then create the plan, and then we'll take it from there. Okay, I saw that a lot of you already solved that problem. We already solved Jack's problem, and we created different devices, and very, very creative. I want to kind of go back and reflect a little bit on these questions. At least one of the or two of the questions at your table, if you discuss with your partners, how did you feel doing this activity? And what meaning making occurred for you as you were working and when you were creating this little bit of a STEM challenge? And what mathematical reasoning did you use as you were working through this problem to help Jack jump over this candlestick? Take a couple of minutes and discuss, and then we're going to have a share out. So if I can hear from a couple of people about the experience that we just had, maybe either one of the questions, what about what meaning making occurred for you? If anybody wants to share on that, if you had time. What happened? What meaning did you take out of this activity? Go ahead.
Saying it has to be teamwork because she had the equipment and I was kind of standing by, we were working together. So
So a lot of communication and collaboration to make it work. So it took teamwork. Right. Really good observation. Anybody else? So you had to kind of plan it out, have a plan together before you actually do it. So you had a lot of trial and error, and then on your way to success, we kept saying, we're on our way to success. So let's keep doing, let's keep. I like that, what he said, that we're on our way to success. Trial and research.
Not there yet. Yeah, that's
so you had to really talk to each other and create a plan together. So collaboration again and planning together. What about some of the mathematical reasoning behind it? Do you have a chance to talk about that?
I was looking at the angle.
So looking at angles?
Yeah.
Just to make.
I know much about angles, just I know enough.
But experimenting. And making sure that he was going to make it safely to there. Because if you kind of push it too far, you were going to send him all the way, who knows. And I think I made sure to say, you need to make sure that he's safely going. So you're kind of going, oh yeah, I need to kind of estimate, maybe. Some of those, go ahead.
Yeah, that's one of the things, like when we had Jack, we had the candlestick here, and when she first did it closer, then he'll be able to jump. So the distance and trying to figure out how hard are you to hit it to be able to go that.
A lot of estimation. And then you said he got nervous.
Yes, he got nervous. Oh, yeah.
He got nervous, like he jumped too
The first time
fast.
it worked beautifully. When she came over here, it didn't work, right?
He was scared. So we always kind of follow the point that I want to make too is that we always follow the children. So our curriculum, when we think about our curriculum, it's dynamic. It moves along with the children. It depends on what the children are doing, the way that this is what we do. So we kind of plan ahead, but sometimes we have to change our plans, don't we? Because it's always dynamic. It's always following that group of children. It's always following what we're doing with children. But the only thing that is constant and predictable are our foundations and frameworks. How many of you are familiar with the foundations and frameworks? Very good.
Oh,
Most of you are really familiar with the foundations. I wanted to show you just really fast the foundations and frameworks for our infant and toddlers, and the foundations and frameworks for our preschool little ones, and now for TK. And just to mention that this is really the constant, that because what do? The foundations and the frameworks. They tell us what the children, a typical child can do at around what months? 3, 18, 36, 48, and 60 months. So they kind of describe to us in a constant continuum what they are able to do. So if we are familiar with this, we're going to be able to support the children. So to follow up with that, the strands and the substrands that are in our foundations and frameworks, especially in the mathematics, you have the number sense, and then you have the algebra and functions, the measurement, geometry, and mathematical reasoning. Just going back to our challenge, our STEM challenge, were we doing any number sense, strands and substrands in that activity? Did you kind of had to understand number and quantity or relationship of operations when we were doing that? Just give me a hands up if you think that we were doing any of that. A little bit? You think so? What about classification and patterning? Do you think we did those? No. What about compare, order, and measure? We were kind of comparing. Yes. What about geometry? Did you hear any shapes? Positions in space? Positions in space. What about reasoning? We were doing, that's the main one that we were doing. And that's one of the reasons to become really familiar with the foundation, so then we'll know what we're doing. Now, you have another handout. Handout number 1B. Take out your handout 1B to go a little bit deeper into the foundations. I know that you said most of you are very familiar with the foundations. We're just going to do a real a little bit of a review. It's handout 1B. Everybody has it out? And in your handout 1B, we have the mathematical reasoning foundations map, and it's 1.1 and 1.1 for 48 months and 60 months. If you read it, take a minute to read the foundation so we can see the differences in a child that is about 48 months and about 60 months, and then we can talk a little bit about the main differences. What are they able to do around 48 and around 60 months? And it's developmentally appropriate. When you look at 1.0, it says children use mathematical thinking to solve problems that arise in their everyday environment. At around 48. And around 60, children expand the use of mathematical thinking to solve problems that arise in their everyday environment. .1 says begin to apply simple mathematical strategies to solve problems in their environment at 48 months. And at around 60 months, 1.1, identify and apply a variety of mathematical strategies to solve problems in their environment. What are the main differences between 48 months and around 60 months that you notice?
Exploring, and then once they pass that, then they're able to go a little further.
So at 1.1, they begin, I would say, they begin simple mathematicals. I would highlight that, and it's exactly what you say. At around 60 months, they apply a variety. They are able to have more variety mathematical strategies. So they're growing, like you're saying, exactly your point. They're growing a little bit more, and they're giving us a few more examples of those, how the children are able to do that. So just a quick taste on the foundations. I know that when you have more time, you'll go more depth into it. One of the things that is really important for us to get to know the foundations is because it tells us what they're able to do, but more importantly, how can we support them? So how can we support our little ones with their mathematical reasoning? I want you to take your handout H2, number 2A, take it out. And how we can support them is by asking them those open-ended questions. Everybody has their open-ended questions handout, which is handout 2A. And look at the kinds of questions that we can ask children when they're discovering and they're exploring the mathematical reason aspect. We can say, are you sure? How do you know that? Remember, like our previous speaker said, ask questions that you don't know the answers to. So these are the open-ended questions. What else can you find that works like this? What would happen if? Could this be changed? What if? I wonder why. You ask them those questions so you can add a deeper meaning and a deeper sense of them, of discovery. I'm going to show you a video with children that are utilizing that mathematical reasoning. What I want you to do is keep this handout out, but I also want you to notice what the teachers are asking. Observe the questions of the teachers. And how are these teachers increasing that mathematical reasoning, and how are they supporting that mathematical reasoning? So we're going to look at children that are at 48 months, around 48 months, and then around 60 months. And your task is to really pay attention how to support, because our job today is to help you increase that mathematical reasoning in children. So we think that if you pay attention to the questioning and how these teachers are supporting those children, you will walk away with some really good ideas back to the classroom. Are we ready to see the video? And you have your handout? Let's look at it.
At around 48 months, children begin to apply simple mathematical strategies to solve problems in their environment.
Our next game, we give the teachers our penguins. And how many teachers did we have? 3. But
I have an idea. We share with the koalas.
how many should we share with the koalas?
2.
2? What's 2?
Because there's 5.
Oh, because there are 5. Okay.
What shape is this?
And half triangle.
Is it? Yes, triangle. How can we
But
cover
look at you
this
can't
space so we
see it
can't
now.
see Mila? Whoa!
Then now you can't see me. But we need one more.
One more.
We
What
need
shape? What shape?
triangle. Triangle. He's in here. He's in here. How about if we get to Al?
Triangle, Peyton.
No.
Look at triangle. You
How
go.
we're not gonna get her out.
Okay.
I got a triangle for mine. No. I got a no touchy, no touch. Can I have more?
How many more would you like? Ask her.
I want 3.
Can you hear her 3 sticks?
Here. That's not 3 sticks.
How many are in there?
1, 2.
How many more do you need?
I need 3. 3 like that.
Wait a minute. We're missing some. How many plates are we missing? We need 3 more? 3 more? How many do you need? Do you want 3? Okay, get 3. We're missing 1.
Now we need 4 plates.
We need 4 plates
And 4 cups.
and 4 cups.
This means we just need 1 plate and 1 napkin. We just need 2 napkins and 1 plate and 1 cup.
Okay, so is this
This is mine. We have to go straight.
How many table settings do we have?
1, 2, 3, 4, 5, 6, 7, 8. Nine.
But what if I take mine away? I don't want to have snack today. Then how many do we have?
Nine.
We have 9. If I take mine away, what will happen?
Let's count. 1, 2, 3, 4, 5, 6, 7, 8.
But you know what? I do want snack. I'm hungry, so I'm gonna put mine back.
9. Now we have 9.
That's right.
You think you can climb up and over? Okay, good. Let's try it.
I want a pillow. I think a chair will be better with me than I think my legs are over too.
All right, we'll try it.
Think of chair. Hey, how about you use this chair?
How's that? Yeah? Okay, here we go. Look up to find a circle. Do you see the circle? Crawl through.
I think I needed another chair here because look at how my short my legs are. Can I be?
Yeah. Try that.
Can I be next after Ted?
Okay, go through. Okay, climb through. Now go down.
At around 60 months, children identify and apply a variety of mathematical strategies to solve problems in their environment.
I can see that.
David, do you have more squares or more triangles in your design?
I think he has more squares.
You think so?
I think more triangles.
How can we find out?
By counting.
How about we do that?
2, 3, 4, 5, 6, 7.
Ellie, did you hear that? 7 triangles? Let's count how many squares he has. Go ahead, David. 7. Keep that in your mind. 7.
2, 3, 4, 5, 6, 7, 8.
So you have 11 squares and 7 what?
Triangles.
Triangles. So which one is more?
11.
11.
And it's
11 squares.
One, two, three, four, five. So, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. No. David, can I have some triangles?
Now you got a pair of triangles.
Yeah, and in this time, since I only need one, look what my design is. Bigger than the top. Bigger than you? It's not that big. Yeah, I do need some more. I'm going to line them all the way up to here.
Is that your plan, putting them in between?
So, have 3 more triangles. Can I have 3 more triangles? Can I please? Me too.
Yeah? Okay.
I don't care. Now I'm gonna finish it right away.
You have tomatoes. Yeah, a lot of people haven't been having tomatoes.
What do we need to start off with?
Money.
Some money? Okay. You want to start off with lettuce?
How much did you pay?
I saw Sophia had tomatoes.
You paid 5 this time?
Yeah. No, but
He paid 5. How do you know?
because
Did you pay 5? Well, how did you know that, Kelly?
I already knew that because that's how many Sophia. Because Sophia had that many,
Yeah.
and she told us, so we know.
So you know Sophia had 5, but why does that mean he had 5?
Because they both had tomatoes. More. We need more. Keep going. Okay, that's enough. You passed my hand.
Okay. And now you two can fill up the other picture, and Daria and I will do the rice milk. So you can fill up the other picture. Daria, if you get the rice milk, we can fill this one up. And you two can fill that one up as well. Do you need me to guide you, or can you do it?
Okay, ask for another pic.
This just needs to be.
We need more pic. That's enough, right? That'll be enough in there.
I think that will be enough. That's plenty.
That'll be enough. Let's measure with the other one.
Measure the other one.
No,
Which has more milk?
that one.
Okay. Which has less milk?
This one. So you need more milk.
We need more milk. Do we have any more milk? I like your teamwork, friends.
Oh, no, that's the same.
Okay.
Which one is the square? There's the middle square.
Which one's the middle? Let's see. Is this the middle?
Okay. So what did you see those teachers doing? Basically, most of them, what were they doing? Asking questions. all kinds of different questions, right? And what were the main differences between around 48 months and around 60 months? What did you notice about the main differences in the children? What were they able to do around 48 months and around 60 months?
Or reasoning.
Mm-hmm.
It's like in the beginning, it's a little bit simpler, and then at 60 months, they're more complex. You notice that at 48 months, the teacher was asking, what shape is this? Very simple questions. How can we cover these spaces? And why? And how many? But when you're at 60 months, do you have more squares or more triangles? Some of the questions, what do we need to start with? And you see the little guy that was climbing, his reasoning was really good when he said, I have short legs, and he was really so cute, but he was right on task what he was doing, and the teacher was doing a wonderful job with that little guy. Anything else that you noticed? Mm-hmm.
But it was a wonderful.
And how the teacher has to be right there and ready to listen and to kind of, what question am I going to ask now so that I can deepen that reasoning for the children? How can I support them? Anything else? Okay.
So while you have a chance, take out your number 1 handout and write down any ideas that you had. We're going to continue on now, and the first thing I want to say is that I'm very comfortable in presenting in front of people, but people on television, I'm not comfortable. So if I sound a little nervous, forgive me. What we're going to do now is we're going to really take maybe a little deeper look at mathematical reasoning. And the first thing I'm going to do is give you an actual definition for the term mathematical reasoning. And it is the process of learning and developing mathematical knowledge in all areas of mathematics. And it's deeply delved into both in the foundations and in the frameworks. In the foundation, page 159, in the frameworks, page 290. The 4 main parts of mathematical reasoning, as you see up here, are think. What a thought that we want kids to think. I mean, really, this is what we strive for, isn't it? Second, reason logically. That little boy's legs were too short for that pillow. He needed a chair. He logically thought that out. That they apply math knowledge. You notice when the girls were setting the table, and you could see the 2 girls were at different levels of development. One had to count every single one, and the other one said, well, there's 9. She already had what we call cardinality. She knew the total. She knew that if they took 1 away, they had 8. The little girl, what did she have to do? 1, 2, 3. So she was still working on numeracy. And is that not the way your classes actually are? I've yet to be in a classroom, and I've been in a classroom for a lot of years, where every child was on the same page on the same day. It's never happened, and I don't think it ever will. And that's part of not only the joy, but it's part of the complexity and the energy that you get from teaching. Those girls, they were teaching each other with the milk, measuring it visually. At the beginning of the 48 months, when the children were asking for 3, I needed 3 more popsicle sticks, and she had 2. No, she said, I meant 3. So she gave her a visual cue, so she was helping, the other child. Applying that math knowledge all the time. Our previous speaker spoke about the fact we don't want to take kids out and say, look at math and trees. No, we don't. But it's there. So when they say that tree has a lot of leaves, it's a great opportunity. I wonder how many, and make a prediction. And no, maybe we're not going to count them, but it's a great opportunity just to use the language of math, which is very important, and create different solutions. Doesn't that suspiciously sound like Common Core? It actually does that. There's more than one way to get to the answer of any problem we have. And there's not just one right way. You know, if I can get to 4 by adding 3 and 1, not just 2 and 2, doesn't change the answer. It simply changes the way I got there. And acknowledging that children have that ability. Now, I want you to think about this. Think about thinking. We have evidence now, and a lot of it is referenced in the foundations, that babies as early as 5 and 6 months of age have some math reasoning. What do? They show them a picture of 1 ball. They look at it. 2 balls. They look at it. 3 balls. And then when they add, and the baby's eyes automatically go to 3 balls, something connects. These are 5 and 6 month old babies. So a lot of this is innate in these children. So they're thinking, reason logically? Do they reason logically? Tear open a package of M&Ms. Pour some into one hand and the rest into the other. Do they notice the difference? Oh, he got more than me. That's reason logically. And they apply the math knowledge. He has 7. I only have 5. I need 1 of his. Again, they may not know the term addition. They may not know the term subtraction. They may not know the term mathematical logical reasoning. But they are applying their mathematical knowledge. They know what equal is. It's like when you give a child a cupcake and have them cut it in half. And any self-respecting kid is going to cut the bigger half for themselves. Of course they are. And then you let the other child choose. Oh, man, next time they have to cut it, they almost get out a measuring tape and measure it to right in the middle. And then they're creating these different solutions. You're going to see a short video in a few minutes from Dr. Clements, who is one of the primary authors of the mathematical foundations. He also has 6 references in the foundations and in the frameworks. And he makes this proposition that children like to play with math. Do they? Ask you. You're the professionals. Do they? How do we know that? That's right. All the time. They love it. And someone had said at the end of the last session when we were looking at that video, those teachers were asking the questions. You never know what's going to happen. But if you are knowledgeable in your field, then you can take that opportunity and jump on it and utilize it. So children like to play with math. We're going to see this video, and then we're going to talk a little bit about what he has to say. Do I have to do anything except push the button? A second time?
Some people would still say, though, that, okay, mathematics is good, but why do it in pre-K? Do you really need to do it that early? I mean, I didn't have mathematics in pre-K, and shouldn't a child just be left to do a child? Oh, yes, a child should be left to be children, certainly. You know what? Children like mathematics. Children see the world mathematically. Herb Ginsberg at Teachers College videotaped children when they were playing. They had no direction. Go play. Almost 50% of every minute of their play involved mathematics. It involved shapes, comparisons, enumeration, counting, comparing quantities, patterning, measurement, something in mathematics, just in their play. Kids like mathematics. They see the world through these kind of pre-mathematical lenses. They might not think of it as mathematics. They might not have the mathematical knowledge to pull it out. But we as adults can look at it and say, they're just poised to do interesting mathematics. So when we do a puzzle, when we count things, when we see who's got more or who's taller, when we see how many of those did you do, how many blocks did you put on top of each other, when you made this building, why did you make this side of the building look just like that side of the building? In other words, a symmetric building that kids might make. We're bringing the mathematics out of kids' everyday activities. Kids like mathematics. Now you still might say, yeah, but historically, kindergarten and pre-K, it was just play and socialization. No, you'd be wrong again. Let's look at the person who invented kindergarten. His name was Frederick Froebel. And more than 100 years ago, he created kindergarten. It was his invention. Everything those kids did was geometric. Those teachers who have ever taken a course in early childhood may have heard of Froebel and may have heard of his gifts and occupations. Well, his gifts were tiles, they were shape sets, they were building blocks, they were parquetry blocks, they were grids on tables, they were three-dimensional solids, and his occupations were build up these kind of three-dimensional solids to make certain kind of buildings, make a symmetric design, copy this design, extend that design, create a pattern. These were the kind of gifts and occupations that formed the original kindergarten. Froebel was a crystallographer, and he believed that God was in the details of geometric objects. And he used that as a foundation for his kindergarten. Ever since then, the building blocks that we now see ubiquitous across kindergartens and first grades and preschools and the like, those were designed as teachers. All you have to do is think about it to know they've got a unit block and a double that and a double that and a half this and two triangles that make this block and everything else. They were designed to provide interesting experiences for children. Unfortunately, with some history going, as the years went by, the math kind of got downplayed. And we still think kids should play with blocks, but we've forgotten a lot of why the blocks were designed that way. Good curricula should help teachers get back to the roots that play and mathematics are not on opposite sides of the stage. They can be combined to the benefit of children everywhere.
Okay, what did you think of what he just had to say? It is the truth, isn't it? Yeah. We sometimes don't understand what our children are doing, and that's when it takes the time of sitting down with them, asking those questions, because their play, their building is very intentional. They have a plan in mind and they're working with it. So we're going to look now at environments and materials because they matter. The environment in which children learn matters. The materials they have matter. They are not the be-all and the end-all, but they do matter. So let's talk about what some of them are. Children need opportunities to explore all of these things that you see up here. Makeup collections. What kind of collections do children naturally gravitate to? The average preschool child. Nature things. That's exactly right. Rocks. We went on a trip when my oldest child was 3. I swear we had to empty the rocks out of the car before we could get over the mountain to get home. We collected so many. It's the truth. But that collection is wonderful because in it things are different sizes, aren't they? And maybe they're different textures. And maybe they have different purposes. And maybe we have a scale or we don't. Or maybe he used the bathroom scale to put all his rocks on to weigh them. These things are necessary. What about who has a junk drawer at home? We all do, right? And it's kind of where you go when you need something, and it's usually there. You don't know what you need, but it's usually there. Think about having this box of things available to children. What are they going to create? It depends on what's in your box, but they will create something imaginative. They will, if they need to build a catapult to get Jack over that candlestick, they may go to their box that has all kinds of odds and ends in it and work from there. They like to have things that link or connect together. I have to tell you that, how many of you know what rainbow links are? The little plastic links that are open? Okay. I had a set of them in my classroom. I had a little boy who really liked math, and we were going through this high 5, high 10, and we were counting by 5s and 10s. And it was the end of the school year, and things were going great. And one day I noticed him. Seth is sitting there, and he's got the rainbow box, and he's got them so that he's the only person who can use them. And he's there, and he's putting them, and he's putting a different color, then he's putting a different color. Finally, I went over, and I said, tell me about what you're doing. This looks really interesting. He said, I'm making a chain. I said, oh, and what are you going to do with it? Do you have a purpose for it? He says, I'm going to measure the room. I said, okay. And he says, and I said, well, tell me about how you planned this. He said, well, I have a pattern, Mrs. Decker. Did you see? You know, and I said, yes, it had red, blue, yellow, green, red, blue, yellow, green. I said, well, They look like they're the same. He said, each one has 5 in it. He said, because that way I can count faster. Remember how we did 5, 10, 15, 20? So he has this long thing that's sitting there, and he pulls it up and he goes 5, 10, 15, 20, 25, 30, 35, 40, all on his own. And then when we got to the point where he had used every rainbow link in the box, we went and it was longer than the room. So then he had to subtract the ones he didn't need to find it out. Then, of course, we had to go and figure out how long each one of his little links were, and all of that got very complicated. But he did that because things linked together. Because of lots of opportunities and experiences to use materials in a school year, he came up with this idea on his own. And, it was interesting to him. It was fun for him, and he did it. And he also he in particular, but other boys in my class, liked to have things that moved. They liked the little cars, and they liked to figure out how they could make their cars go faster than their friend's car. And so this all led to using blocks in an incline, and how high the incline was, and how fast it would go. And all of this came from not only having materials and having an accepting environment in which they could do that, it came from allowing them the time to work on it, not to limit their time. One of the things that I don't know if we have any TK teachers in here or not, maybe we do out in television land, but one of the things that the TK guide says is best practices say children should have a minimum of 45 minutes free choice play a day. Think about that, 45 minutes. And think about how many times we are rushing our children from one area to another area. They need the time, they need the opportunity, and finally, they need to have a purpose for what they're doing. Just go play in the blocks or play with these manipulatives isn't enough. They have to have a purpose of what they're doing. It needs to be purposeful for them to take an interest in it. Does that make sense? Okay, good. Okay, well, we don't have these things here in reality, but let's quickly talk about how you could use these in a math-connected way. How about magnifying glasses? Most classrooms have those. How are you going to use those? Bigger and small, absolutely. And the near and far. Okay, and can you think of any others? What about tongs? Grasping one-to-one correspondence. This is what we're talking about. We don't necessarily call these things by what we're doing when we're doing them, but if we are purposeful and knowledgeable in what we're doing, then the children will be getting what we want them to get from it. What about measuring cups? How many parts are in it? What about measuring cups and shovels and put them in the sand area? Because remember, the classroom isn't the only learning environment. The outside is the learning environment as well. What is that going to be able to help our children do? Figure out how many it takes of those quarter cups to make a full cup, and then how many of those full cups it takes to fill a bucket, and all of those mathematical concepts. Scales. The weight, the balancing things, getting it to balance, learning that if you move the balance out further, that it changes how the balance works. Thermometers, not just ones that we put in our mouths, but other kinds of thermometers, meat thermometers, the ability to see these things. Have microscopes. These are all wonderful tools. Not all of us have these tools, but there is a handout 2B on the back of your questions that has a lot of lists. Look through here. Add quickly, because we're running out of time, anything that you would like to add to your area. We're going to talk quickly about, while you're doing that, I'm going to keep talking. We're going to be talking about this extending arc. If you think about a rainbow, when we usually see a rainbow, we see a portion of a rainbow, don't we? We see it arching. What we want to arc here is how much deeper we get into the ideas, not just counting. Not just, can I count to 10? Can I count to 20? Do I know what 10 is? Do I know what the concept, that quantity is? And so we want to get always deeper. When I first started working with CPIN, we used to have this thing that we did when we did math workshops, and it was about the fact that generally we teach an inch, a mile wide. We teach a little bit about everything in math, but only an inch deep. We need to go much deeper. That is the place where children are going to learn. It's going to be so much more easy for them to understand mathematical thinking if they've had lots and lots of experiences. We want that arch to go, go, go. Really keep going. I'm in your frameworks. I want you to know that each domain has its own set of environments and materials. Each also has its own description of interactions and strategies and what appropriate play spaces are. And again, I'm going to get to what I think is the meat here, which is the conversations. The ability for that teacher, that person who is leading the group, to ask those questions, because that's where the learning takes place. And just as importantly, as the speaker this morning said, not just ask the questions, listen to the answers. Wait for the answer. Wait for the child to tell you. Okay, so we're going to go here. I'm going to skip this. You have it there. What can you add to your environment for math opportunities? But since we have only like 5 minutes left, I'm going to skip this because that's something you can do later. But this I don't think can be skipped. This is, we talked earlier about open-ended questions. Now, I've seen these questions used a lot of different ways. Some people, it's hard to remember all the questions you want to answer, and it's not always what we're thinking about. I've seen teachers take these and put them on cards and have a set of cards at each learning center. I've seen teachers put them on bracelets, literally on bracelet, all the different questions. And I've also seen those plastic bracelets that you can get for very little money, the question written on it, put on a stand in the middle of the table, and the child will pull out the question they want to be asked. So this is what it is. This is how we ask. What do you think is going to happen next? Is that cutting off our arc, or is it opening it up? It's opening it. How can we find out? Again, we're not going to look it up in a book, and we're not going to Google it. We're going to try it. We're going to do it ourselves. What makes you think so? He has more M&Ms than I have. What makes you think so? Because I counted. He's got 5, and I only have 3. Okay? What do you observe about it? When we're going to try this out, they have to take the time to then observe the activity. And how can you describe it? Children describe things, as you all well know, differently than we do. They don't have our ability with language yet. So many times they will explain things to you in a way that you're not understanding what they're saying. And if I have that problem, I say, can you show me physically, or can you draw it for me, which helps? Can you think of another way? If this didn't work, can we think of another way to do it? How do you think we should investigate this? Let them have the input. What should we try next? If the first part of our experiment is working or not, what do we try next? Again, I go back to, I love that phrase, try and results. We're going to get a different result, but we're going to learn as much from that result as we are from having been successful. How will we measure this? Are we talking about physically measuring, using a ruler? Are we going to measure it because of how many people like it? The different ways. And how should we record it? Because very important part of our job is recording and documenting what children have done. And what are some of the ways we can record what they've done? In this age of technology, we have pictures that we can take. We have video we can take that actually shows them doing what they can, record it by writing, all kinds of things. Say, whew, this is really quick, isn't it? Sorry, but I want you to think, because I think this is really important. I've been in this field, as you can tell from my white hair, a very long time, and I love it. I'm as passionate today about early childhood education as I was the first day I got into the field. So what did you experience in this? And we had a great activity to do, but we don't have time to do it. Let me just show you so you would have known what it was. All you were going to be given is a couple of pieces of yarn and a bunch of pom-poms. No directions. You tell me, what could you have done with this? Come on. You could tie them and make a bracelet. What else could you done mathematically? See how long they are.
Line them up again along.
Classification. Sorting by how many ways? So you could have a Venn diagram by size, by color, by attribute. You could have thrown them. You could have made a circle out of this and thrown them and estimated how far you could throw them. And then you would find that little ones that weigh very, very little aren't going to go very far, are they? So all of those things, this is the kind of thing, that activity that is simple to do. Children love it, and yet they are constantly getting different levels of understanding. The first time they do it, it's fun. It's just fun usually. The second time they do it, oh, I can classify these. I mean, that's not what I'm going to put them by color. Each time it's deeper. That's why it's really important to repeat things. So what did you experience today, and maybe the first activity that you did that made you think about mathematics and mathematical reasoning in perhaps a different way? And how do you continue to think about it? How do you continue to think about opening up this arch? What is something we may have given you today in the form of a handout or an activity that has opened up an idea for you? Because reflection, mindful reflection, is absolutely crucial to children's success and your feelings about yourself as a teacher, right? We want to do the best we can do. And things don't always, I don't know about you, I didn't have any perfect days ever. Always worked at perfection, but it never kind of got there. So what are we going to do differently next time? How are we going to make it better? Always reflecting on that. And I know you have just loads of time in your classroom to sit back and reflect. No, we don't. And so that's perhaps the most crucial thing is, how are you going to make the time? Have the energy to add these new ideas, these new desires for your kids, these new accomplishments for them, the competency, the fact that they've learned one-to-one correspondence, cardinality, subitizing, all of those things that you have been able to impact on them and to give to them, and they've been able to learn for themselves because of the materials and the environments you've provided. So think about that. And thank you for giving us your attention and building your knowledge with us.